on Friday, which is dealing with completing the square. How is this lesson different than Friday? Well, we're going to have to flex our mathematical muscles a little bit more here because, for example, in the question that Brody had asked about, we factored the 6 out, and we were lucky enough that the other term was 24x. 6 divides into 24 nice and tidily. But what if it was 23 or 11? We have to be able to cope with that. So it's not that the questions we're going to be doing today are going to be all the questions they're going to be like from now on. You're still going to see ones where things factor nicely, but every now and then we have to be able to do these. We're also going to look at some more word problems that involve max-mins, but we're going to solve them algebraically, which I can tell you right now would be a classic kind of written response on an exam question, where in order for you to find the coordinates of the vertex to answer the question, like what's the length of the pen that will maximize the area, in order for you to find the coordinates of the vertex to answer that, well, you got to complete the square and not just find it on your calculator. And that will be a relief to some of you because then you don't have to worry about window settings and zoom and all that. Okay. So we're going to convert each of the following quadratic functions to standard form, and then I say draw a rough sketch showing all properties, but really what I'm interested in here is us being able to discuss all of the properties, like does it open up or down? What's the equation of the axis of symmetry? What's the range? All of that stuff. And again, I hope everybody understands that since it's 4x squared, and 4 is a positive number, this parabola opens up, which means there's a minimum, and we already have a lot of information about the function just knowing it opens up. What we really need is the vertex. If you knew the vertex and it was opening up, then you could answer anything about the function. Well, that's completing the square. Some of you will be a little more at ease by just writing y equals as opposed to f of x, and that's fine. Equals 4x squared plus 10x. And just like the question that Brody had asked about, I'm going to go plus 5, but I'm going to shuffle it out of the way. I'm just going to store it away someplace, and not so far away that you forget it's there. Okay, I think I mentioned that sometimes people will write it way over there and then they just forget about it. So I cannot start to add a number to make this a perfect square trinomial until the coefficient of the x squared term is 1. So I need to factor 4 out of the x squared plus 10x. Now, I want to go back and just look at the one that I had gone over, where I factored a 6 out. And what happens, I'll erase some of this so we can just focus on what I want to talk about. What happens when I write, I just want to focus only on the factoring out of 4 out of 6x squared plus 24x. I mean, if you're like me, you kind of just, you're on autopilot. You just write, well, it's x squared plus 4x. You're not even really thinking about it too much. But if I ever do have to think about it, and I say to myself, what goes here when I factor the 4 out of 24x? Invariably what I do, and I don't know if you're this way, is I say, what would I multiply 6 by to get 24? That's what I do. How many of you think that way? It's a very common way to think. So the answer is you multiply 6 by 4 to get 24, so you get 24x. That kind of breaks down a bit, though, because if I were to go to the question we're working on now, and I say, well, I factor 4 out of 4x squared and get x squared, plus, and then I say to you, what do you multiply 4 by to get 10? That's more confusing, isn't it? It's not obvious. We're not on autopilot. We've got to really think about it. So instead, what we do is we remember that when you're factoring, you're actually dividing. So one way to look at the fact that this is 4x is it's going to be equal to what we started off with divided by what we factored out. And 24 divided by 6 is where the 4 comes from. So for that reason, when we're factoring, we're dividing. When we take a look at this, what do I have left when I factor 4 out of 10x? I have 10x over 4, which is 5 halves x. And look, I'd rather you can do that without a calculator, but when push comes to shove, what you need to be able to get is 5 halves x. Or whatever the fraction is, you do not want decimals here. 10 divided by 4 is 5 halves. So we're left with 5 halves x. Now we're going to leave room to add something. We also have this plus 5. And what we're going to add is half of b squared. And I really don't want you to use your calculators here, okay? I don't. I've taught this course many times, and it always comes down to the same conversation. There is going to come a time where if all you know how to do is plunk things into your calculator and go math, enter, enter, that you are just going to fall by the wayside in high school math. It's going to happen 2 more units after this one. And this is what I mean by flexing our mathematical muscles. You guys know how to complete the square. Well, what if it's a little more complicated? Can we do it? So what we're doing here for this piece is we're taking half of 5 halves. That's what I would recommend is the best way to think of this. We're not taking 5 halves divided by 2. That gets messy in the head. We're taking half of 5 halves. And that means we're multiplying b by a half, and then we have to square it. So when I multiply fractions, I multiply across the top, I get 5. Across the bottom, I get 4, and I have to square it. So the number I'm going to add is 25/16. Again, you have to be able to do this on paper. It's not just a calculator thing, okay? So we're adding 25/16. And this is all just, I mean, I guess it is work that we would show on a written response, but in terms of our lesson right now, I'm not too concerned about it. As long as you know how to algebraically, which means without a calculator, get that. I mean, if you have to use your calculator to figure out that 5 squared is 25, that's fine. But you have to be able to set it up just like I've got it there. So now what do? We have to take away something. We've upset the balance of that. And it's no different than the questions we did on Friday. We have to multiply this 4 by this 25/16. And look how I wrote that 25/16. Some of you may not realize yet how important this is. You don't, unless you're really, really good at math and you understand fractions like you're golden with them, you would never write this. You don't do that where things are kind of all over the place vertically. That 4 is 4/1. It's a fraction, really. And we're multiplying it by another fraction, so it's nice to keep things, all the numerators aligned, all the denominators aligned. Now, I know that when you multiply fractions, you multiply across the top and you multiply across the bottom, but we can still reduce common factors on the top and the bottom. There's a 4 someplace on the top. There's a 16 someplace on the bottom. This only works if you're multiplying fractions. You would never do it if you're adding them. So 4/16 is equivalent to 1/4. In other words, this 4 cancels with 4 out of the 16, and we see that what we've really added is 25/4. So that's what I need to take away. So up here where I have plus 5, I'm going to take away 25/4. Let me rewrite that without all of this stuff in between so we can just look at it before we do anything else. We have y equals 4 times x squared plus 5 halves x plus our 25/16. And then we have plus our 5 and minus our 25/4. So we're just a twig away from being done here. One of the things we need to do is write that perfect square trinomial, which has a 4 in front of it, as x, and then with a number, quantity squared. So how do we get that number? What number do we put there? Well, sometimes it's useful to go back and review simpler examples. Like, for example, if I had x squared minus 6x plus 9, I would put x minus 3 here. And we talked about this on Friday, and a lot of you wanted to say, well, yeah, because 3 squared is 9. And I said, well, that's true, but I would rather you say negative 3 is half of negative 6. So, and I'm doing a bit of reviewing here. When we figure out what number to add, we take half of b and then square it. When you're figuring out what number to put in the binomial, it's just half of b before you square it. So what did we get when we took b, which was 5 halves, we divided it by 2, we got 5/4. So this is plus 5/4. It's always half of b in here. And now we need to figure out what this is. And, again, I know the temptation is there to just grab your calculator. You're not helping yourself. You're hurting yourself. And I wish more teachers at earlier grades would stress that to you, that it may seem easy, but what's easy now becomes really hard later. So what we need to do is take 5 and subtract 25/4. Now listen to how I said that. I'm really going back and teaching you some elementary junior high math right now, but I didn't say we have to take 5 and subtract 25/4. I never think of 25/4 as 25/4. It's 25/4. And the reason why I can't subtract 25 minus 25/4 is 5 is not quarters. If I want to subtract quarters from quarters, I can, or chickens from chickens, I can, but they got to be the same kind of thing. So this is where the idea of putting this over 4 comes from, the idea of a common denominator. If I had that first number, which is 5, if I had it as something over 4, then I would have quarters minus quarters. That makes sense. So I have to multiply the top and the bottom of this fraction by 4, and I get 20/4 minus 25/4, which is negative 5/4. I mean, the analogy with negatives kind of breaks down with chickens and cookies and stuff like that. But when you have 20 of something and you subtract 25, you're left with negative 5. So this is our answer, negative 5/4. That's the answer. I don't want to get too hung up on, 5/4 for both, eh? That's interesting. Go ahead. Yep, I'm with you. No, it won't hurt, but it won't be as useful. Because what's going to happen, just to get off the beaten path here for a bit, is we might have something like that, where we have to put these things together, which means the common denominator would be xy, and you would have to multiply top and bottom by x. And then what you're doing, and I understand exactly what you're saying, it isn't helpful. I don't think it hurts us right now, but it's not helpful. You're still thinking of a common denominator in a way. So that is a fluke that we end up with A is 4. P is negative 5/4. Of course, P is always the opposite of the sign in with the X in the vertex form. Q also happens to be negative 5/4. So the vertex of this is in quadrant 3 at negative 5/4, negative 5/4. There's nothing wrong, by the way, of figuring out that 5/4 is 1.25 and saying, oh, it's negative 1.25 comma negative 1.25. The parabola opens up. It's quite narrow because of that 4. I'm not going to write down all that stuff. The axis of symmetry is x equals negative 5/4. There's a minimum value of y equals negative 5/4. The range is y is greater than negative 5/4. You guys can figure out all that. I want to focus again, like Friday, on completing the square. Try one more. So x squared minus 7x plus 15, we want to complete the square. Now, luckily, with this one, it's ready for us to load in the number that makes part of it a perfect square, because the coefficient of x squared is 1. So when I write this as y equals x squared minus 7x, and then I move the 15 over, I am ready to add that number to make it a perfect square, because the coefficient of the x squared is 1. We don't have to factor anything out this time. Just check, is this the exact same function that's on your handout? Okay. So I want everybody to figure out what number we add here. And I want you to see if you can figure it out as a fraction without using your calculator to calculate the fraction. If you need to use your calculator to square a whole number, fine. How many of you have it, by the way? Yes, you have to take b, which is negative 7. You have to divide it by 2 or multiply it by a half and then square the result. And don't mistake what I'm asking you to do with me saying do it in your head. You might have to write some stuff down, right? I'm just saying don't rely on your calculator. So what number are we going to add here? Well, we're going to take b, which is negative 7. We're going to cut it in half or multiply it by a half, however you want to look at it, and then square it. By the way, everybody, when we get down to the y equals x something squared, this will be that, right? It's what you get before you square half of b. So negative 7 squared is 49. 2 squared is 4. So I have to take away 49 over 4 somewhere else. Why did I not have that extra step of multiplying what I wrote by something else? Because I didn't have to factor any number out. There was no 3 I had to factor out. So now we're just about done. This becomes x minus 7 halves, quantity squared, and I need to figure out what this is. So the common denominator would be 4. In order to go from 1 to 4, I have to multiply by 4, so I have to multiply the top and the bottom by 4. And last I checked, that's 60. 4 times 15. So I have 60 quarters minus 49 quarters. 60 cats minus 49 cats is 11 cats, so it's 11 quarters. And we're done. The vertex, well, let's write our A, P, and Q just for kicks. A is 1. P is, careful, P is 7 halves. That's a little tricky. Because I focus and fixate and tell you, oh, this thing I've highlighted, that's what goes down with the X. But that thing that we've highlighted is not actually P, it's the opposite of P, because it's X minus P. And then plus Q is 11/4. So the vertex of this is at 7/2, which is 3.5, comma 11/4, which is 2.75. The vertex is there, and it opens up. And from there, you could tell me anything. You could tell me whether there's a max min. You could tell me what the max min is. You could tell me what the axis of symmetry is. You could figure out the domain, range, all that stuff. Any questions with that second example? So the goal here is it doesn't matter if the numbers work out nicely or not. They're decimals or fractions, you got to be able to handle it. We're going to do 3 word problems here. But we're going to do them algebraically. Of course, parabolas have maxes and mins, and in this case, you're given the height of a projectile after it's launched. Maybe it's a water balloon from a water balloon launcher, maybe it's a rocket, doesn't matter. What's the maximum height above the ground, and how long does it take to reach the maximum height? So this is really pretty easy because we're given the function, right? We don't have to make up the function. And how we did this in the past was you used your graphing calculator. But I want to highlight for you what we did in the past is still the basic principle, even though we won't use a graphing calculator. Namely, if this is what the graph looks like, where the vertical axis is height and the horizontal is time, then this point that you're looking at up here is critical to answering the question, because that point corresponds to the maximum height, and this x value is the time that it takes to reach that point. And I hope it's not lost on you that that point's the vertex. So we need to complete the square of this to find where the vertex is, that's all. The nice thing about these questions is when I want to know the maximum height, it's going to be a decimal. Multiple choice, numerical response, written response, we're going to want a decimal. I don't want, you don't say to the engineer, oh, the maximum height of the rocket's going to be 1172 thirds. You don't say that. You just give the decimal. So we're allowed to work in decimal form. All right. Well, let's do some factoring. I have to, and if you are more comfortable, drop the function notation. Don't say h of t, just call it height. It just means height is a function of time. I still recommend moving this 28 over, rewriting it and moving it over. Realize you don't have to, but I think visually it's more helpful. So now I can factor out the 5, the negative 5. And I'm factoring a negative out of a positive, so I'm left with a negative. I don't have any problem with you taking 62 divided by 5 and figuring out that it's 12.4. I don't know. 62 divided by 5. You can use your calculator. It's 12.4. So we're going to have minus 12.4 t. Plus, I'm going to leave room for my mysterious number that I'm going to add. I also have plus 28. And then I'm going to have to do a correction here. So what number do I add? Well, I take 12.4, negative 12.4 over 2. Let me rewrite this. I take negative 12.4 over 2, and I have to square it. That's the number I'm going to add. And again, because I know I'm kind of contradicting myself, but this isn't an algebra problem. This is an applied math problem. Decimals are okay. So 6.2, I couldn't tell you what that is squared. I have to work it out. I could, but sometimes it's okay to be lazy. It's 38.44. I didn't even include the negative because I know it's going to be positive. So 38.44. I do not want to just subtract 38.44. I have to multiply these two things together. Negative 192.2. So by writing plus 38.44, I've actually taken 192.2 away, which means to correct that, I'm going to have to add 192.2. I have to do the opposite. My height is -5. T, it will be minus because it was minus for our t's, and it's minus half of that number 12.2 squared plus 220.2. Thank you. And you've answered the question now. I mean, I'm not just going to leave you hanging there. I'll write down the answer in a second, but the maximum height is 220.2 meters, and it occurs 6.2 seconds after launch. So going to this diagram, if this point is 6.2 comma 220.2, then this time is 6.2 seconds, and this height is 220.2 meters. How many of you is it the case, just by a show of hands, that when you see this final thing that we have written, how many of you, by a show of hands, see the answer to the question there? You know how to interpret it, right? The maximum is Q. Let's not forget this is A times X minus P quantity squared plus Q. The maximum is Q. It occurs when P, and that was on day one. We always said, well, when we talk about the maximum, it's the maximum value of Q or of P. Or sorry, it's the maximum value or the minimum value of Q, and it occurs at P. All right, let's try another one. This time we're going to have to come up with the equation on our own. This question should be familiar to you. You've never seen this one before, but it's like a question we did. It's like the water bottle question. Let's read this together. It says at the last concert somewhere, they sold 7,200 tickets when they charged 45 bucks a crack. A research company, an economics advisory company, has come in and told the concert promoters that, you know what, if you increase each ticket price by $4, market research indicates you'll lose 20 fewer tickets. And of course, some of the people working with the concert promoters company would automatically say, well, we don't want to lose people. But then the economist tells them, yeah, but you'll get more money. You get more money unless you increase it too much. And what you would be interested in is what's the optimal price for the ticket, which means what should we charge to get the most money? I don't care how many people we get. I don't care how much it is per ticket. What I want is the most revenue. So we are trying to maximize revenue, and revenue is number of tickets sold multiplied by the price per ticket. And this is when I say it's a classic kind of question, it means you need to know how to do this question. This is a good written response question. We need to introduce a variable. And I'm trying to teach you not just how to do this question, but how to do max-min questions. If you are after maximum revenue, then what we want to do is wrap our head around a revenue graph where we can see in our head anyway that there's a peak. But that means you need another variable. You need some other variable here, and I'm going to call that variable x. I'm going to call that variable x. But we have to define what x is. X is the number of $4 bumps in ticket price. So let's not lose sight of the fact that X is not the ticket price increase. X is not the ticket price. It's not how much it goes up by. It's how many $4 bumps we give to the ticket price. So if X ends up being 1, that means we need to raise the ticket price by $4. If X ends up being 1.5, which it could, then we need to increase it by $6 because 1.5 fours is 6. So what's our equation look like? Well, our revenue is the number of tickets sold. Now, did they say they sold 7,200? And that's going to go down, isn't it? So we've got 7,200 and it's going to drop. We'll get to how much it drops by in a second. The price per ticket was $45 a pop. That's going to go up, right? So the first thing is when I see people do this question, sometimes they get the plus and minus in the wrong place. Be very careful. It says you're going to increase the ticket price so the ticket price goes up. Now, how much does it go up by? It doesn't go up by X. It goes up by 4X because it goes up by $4 for every X. How many seats do we lose? Well, it says we lose, I thought I saw 20, but I'm not sure. Yeah, we lose 20 customers for each $4 bump. Well, that would mean this would be minus 20X. So how are we going to find the maximum revenue? There's going to be a parabola that looks like this. I can tell it's going to look like that because negative 20x times 4x will be a negative number of x squared, so it will open upside down. Well, what we need to do is convert this to standard form first so we can complete the square to determine where the vertex is. So we have to, there's algebra now. We have to FOIL this out to get the standard form, then we have to complete the square. Of course, we're going to use a calculator to multiply things like 7,245. We're not going to say, oh, you got to do that in your head. It's math 20. So 7,200 times 45. We're going to be reasonable and say it doesn't matter what math you're in, you're going to do that. So my revenue is 324,000. My outer is 4x times 7,200, which is 28,800x, negative 28,800. Somebody help me out. Okay. Is that right? Okay. My inner is 20 times 20x. It's actually, yeah. I don't know. It's not. It's positive. Thank you, Ariana. Outer is 7,200 times 4x, which is positive 28,800. Thank you for that. My inner is negative 20x times 45, which is, I believe, negative 900x. Seeing a few nods. And my last is negative 20x times 4x. Negative 20 times 4 is negative 80. X squared. "58 eyes are better than 2, so let's just take a look at our work here and see, does that look okay? She wish you could write an exam that way. Class effort. Sorry. So now we're going to simplify this and do one other thing, which is to rewrite it in standard form, which means put my x squareds first. I don't know if my subtraction is right there on the 28,800 minus 900. I believe it's 27,900, and it is. So again, get a couple of confirmations on that line. This is where, seriously, everybody, graphing that on your graphing calculator and finding the window settings to make it work with those big numbers is really frustrating sometimes. Let's complete the square. I'm going to do something here that I don't really recommend, which is to not rewrite the line with the 324,000 separated. Okay, I'm factoring while I'm moving it over, which is it's a little risky. So you do too many things at once, you might make a mistake. Plus, minus, because I'm factoring a negative. I guess I just have to take 27,900 and divide by 80. I'm not up for that. 348.75. Yes or no? Yes. So it's minus 348.75 x. Now we're going to have to add in a number. What number are we going to add? Again, we're not going to worry about this as a fraction. When the concert promoter wants to know what to charge for a ticket, they don't want it in a fraction, they want it in money. So I'm going to divide this number by 2 and square the result. So half of B is 174.375. It's actually negative, but when I square it, it goes away. So this is the number that I put here, 30406. We do want to carry as many decimals as we can. Now I have to multiply this and this to find out what I've really done here. What did I really do? I mean, I wrote that number, but the fact of the matter is, times negative 80, I have actually subtracted that number from the right side of the equation. And that means I need to add that number somewhere else on the right side. And I would say to you that maybe one of the more challenging parts to this question is just keeping track of all the numbers, because there's so many decimals and digits. So I need to add, let me write that down first. We subtracted negative 2432531.25. So we have to add that. 2432531.25. I almost like questions without these numbers better, where I can do the math without a calculator. This is going to become negative 80. I will have x minus half of this, which was that 174 point, do I still have it? 375. Squared, and then plus this, which will be our maximum revenue. Whoops. So I need to take that 324,000 and add and get 2,756,000. 2,756,531.25. So forget about how realistic this is or not. The fact of the matter is the vertex is at 174.375, comma, this number. Which means I won't go back up, I'll just redraw it, that your revenue graph looks like this. This occurs when X is 148.375 and your maximum revenue is equal to that $2,756,531.25. So let's answer the question now. One of the things it said is, what's your maximum revenue? Done. I believe we were also asked for how many tickets are sold and what's the price per ticket. Well, the price per ticket was 45 plus 4x, and x is 148.375. It's going to be expensive. It's like the Rolling Stones, although I saw a picture of the Rolling Stones on a news site the other day. They look like they're ancient, like 80s or something. They look like a bunch of old guys. Question? Oh, look at that. I don't even know where I got that from. Thank you very much, Ariana. This is 174.375. So can you work that out for me, please? 45 plus 4 times that. 340. Oh, I know where I got the 148 from. So 742.50. That's the price per ticket that you would have to sell if you wanted to maximize your revenue. How many tickets would you sell? You know what I would do? I would just take the maximum revenue divided by this number. Or what you could do is say 7,200. Let's figure this out. Minus 20 times the 174.375. Let's find out how empty the arena is going to be, even though they're going to make lots of money. It'll only be the rich folks that are going to be buying the tickets. Going to turn off a lot of people. 7,200 minus 20 times the 174.375. It's about half full. 3,700. Obviously, they're not, you don't have 3,712 and half a person, right? You'd just say 3,712 or 3,713. Any questions with that example? One final example, it's the old area problem that we've done at least twice already. Let me summarize this for you. We want to construct a pen for poodles and pit bulls, and we want to use the side of the barn for one of the sides of the pen. So this is what it looks like. You've got your barn here. And we're going to construct the pen this way. Which means that this pen has a length and it has 3 widths. And I'm hoping, since this is at least the 3rd time we've done an area problem, it's starting to gel in your head as to what to do. Area is length times width, but we don't want 2 variables defining area, we want 1. Because if you have 1, then you can have a graph of area as a function of that variable. Well, the equation of constraint based on this is that 600, is yours say 600? Okay, thank you, equals L plus 3W. I really hope it's clear that we want to rearrange this for L and get rid of L, even though we could rearrange it for W to get rid of W. If we rearrange it for W, we're going to have fractions. because you're going to have to divide everything by 3. So what I would do is rearrange it for L and get A equals L, which is 600 minus 3W times W. And this one will be quick and easy to answer from here, not a bunch of weird decimals. When I expand this out, I'm going to get A equals negative 3W squared plus 600W. And now I'm ready to complete the square. So I'm going to factor out a negative 3. This is a case where some of you asked the other day, well, what do you do if there's no number here? The number is 0. So I factor out negative 3. 600 divided by negative 3 is negative 200. In a long day, can somebody just confirm? I'm sure that's right, right? We're ready to load in our mystery number. We take half of the negative 200 and then square it. Which gives me, just confirm for me, it gives me 10,000. Thank you. So would you be okay if then I said minus 10,000 here? You would? Nope. Very common mistake to forget to multiply by that thing that you factored out. Right? And I mean really common. Be careful about that. What we've really done, since negative 3 times the number we wrote in is negative 10,000, we've really added negative 10,000 to the right side. So to undo that, we're going to add positive 10,000. Or we've subtracted 10,000, so we're going to add 10,000. I'm just curious, how many of you see that this, 10, 30,000. 3 times 1 is 3. Okay, 30. Sorry. At least, even with masks, I can see that you're telling me I've done something wrong. So this is plus 30,000. My question was going to be, how many of you can see this is the maximum area? That's your Q value, which is the maximum. When we write this in vertex form, we are going to have W minus 100 quantity squared plus the 30,000. So this parabola would have a vertex at 100, comma 30,000, which means the maximum area is 30,000, and that happens when W is 100. So what's L then? We would have to go back somewhere. I suppose we could just use the fact that L equals 600 minus 3W. So 600 minus 3 times 100 is 300. Or you could have taken the area that we got, which was 30,000, and divided by 100 to get 300. Anyway, it's 300 long and 100 wide on each of those 3 sections. Questions with that final example? All right, so we're done the unit here. There's some questions that you can practice. You don't have to do all of these, okay? But when you look at them, complete the square. There's decimals. By the way, if you're given decimals, work with decimals. There's some where you're given fractions. If you're given fractions, work with fractions. And then there's some word problems as well. Again, you don't have to do all of these. I just want you to practice some more complicated completing the square problems. So you got about 15 minutes to work on these. And just give me a couple of minutes to take attendance, and then I'll be right with you.